Good day, class. My name still remains Mr. Adebanjo of Mathematics Department, Christ the King Catholic College, Adetola. Today, class will be focusing attention on polygons. But what do you stand to benefit from today's class? So we are going to be looking at definition of polygons. We'll also be considering what polygons are and what they are not. We'll look at the classification of polygons, whether concave or convex, whether regular or irregular. Then we'll also get familiar with polygons names from 3 sides to the last one. Apart from this, we will be looking at classification of triangles based on size, based on angles. All this will be discussed in today's class. And lastly, we will also be looking at quadrilaterals, different types of quadrilaterals that we have. So all of these will be the main focal point of our discussion for today's class. Please sit down, relax, and enjoy the class as we continue. So in the meantime, let's start with what polygons are. Polygons are a closed figure formed by line segments so that each segment intersects exactly two others, but only at their endpoints. Please take note of that last statement, or last phrase rather, but only at their endpoints. So that will take us to what polygons are not. We can see that first figure are not meeting at the endpoint. So that cannot be seen as a polygon. We can see another one. There is intersection, so polygons must not have any kind of intersection in between. You can see another one. Then, so we can see the gap between the ends, they are not meeting. So that faded line tells us that they're supposed to meet, but they are not meeting. It's just telling us that there is a gap between the one an end and the other end. So all these are not polygon. All these figures that we have seen from the left hand side of the slide are not polygon. But let's now see what polygons are based on the definition given to us. Polygons are this, you can see it, closed figure, you can see it, no intersection or whatsoever, closed figures, all these are what? Polygons. But now let's move on to having understood what polygons are, let us now discuss the classification of a polygon. Polygons can be convex, that is, no line containing a side of the polygon contains a point in its interior. Then we can see an example of convex polygon. Then we have concave, a polygon for which there is a line containing a side of the polygon and a point in the interior of the polygon. Then we can see the diagram telling us much more on the definition of a concave polygon. Then we also have classification of polygon, either regular or irregular. So what are regular polygons? They are convex polygons in which all interior angles have the same measure and all sides are of the same length. So we can see an example of a regular polygon. Then we have irregular polygon. What are irregular polygons? So these are polygons that have two sides that are not congruent. And even their interior angles too are not congruent. They are not the same. Then we say they are irregular polygons. We can see the diagram. Now, moving on to polygon names. So the first one, since we have come from the definition of a polygon being a closed figure. And how do we have a closed figure? So it means that lines must meet to form a closed figure. So if you just have two lines meeting, it cannot be a closed figure. Then that is why we cannot start from 2, because if you have just 2 lines, then there is no way those 2 lines will form a closed figure. So starting with 3 lines, then we can see that, okay, it is feasible that if the 3 lines are properly drawn, then we can have a closed figure. And that name given to such is triangle. So for four sides, then we have name given to it to four side polygon as quadrilateral. So for the five side polygon, we have it as pentagon. For the six side polygon, we have it as hexagon. Then for the seven side polygon, we have heptagon. For the eight side polygon, we have octagon. Then for the nine side polygon, we have nonagon. So for the 10 side polygon, we have decagon. For the 12 side, we have dodecagon. And for the n side, we call it n-gon. N-gon. So these are names given to polygons. Then let's now talk about the regular polygons. So what are regular polygons? Regular polygons are having these properties. All side lengths are congruent. That is, all of them are the same. All angles are congruent. That is, all the angles are the same. So that's regular polygon. We can see the examples. Then we want to talk about the area of regular polygon. Then there is something called apothem of a polygon. So apothem of a polygon is more or less like radius in a circle. That is a line coming from the center of a polygon touching the side of the polygon. That's what we call apothem. Apothem. So if we want to understand that clearly, we want to clearly fix in our mind the radius of a circle. That is, if you talk of circle, there is a line coming from the center to touch the circumference. But in the case of polygon now, there is a line coming from the center of the polygon touching the side of the polygon, and that is called apothem. So we can see it from that diagram. So when we have that apothem, then we can now use the apothem to use that perspective to divide that polygon into subdivision of various triangles. And then, so with this in mind, then we apply the perception of area of triangle, that is half base times height. But in this case now, the area of this polygon will now be half times the side times the apothem times the number of sides. Don't forget, the x stands for side length, that is the measurement given to each side. Y, the apothem, is the distance from the center of the polygon to the side of the polygon. And so Y, the end there, tells us how many sides does such a polygon have. So with this, we understand the area of polygon. So we want to clearly fix that in our minds, that area of polygon, when we remember area of triangle, then we have something similar in polygon, that is x. Instead of base in triangle, then we have x replacing that base to become the side length. Instead of height, then we now have apothem, that is the line coming from the center of the polygon to the side, and the number of the sides. So all these coupled together give us the area of regular polygon. Then let's quickly talk about triangles and quadrilaterals. Then how do we classify triangles? So we use two major yardsticks in classification of triangles. We use sides, and at the same time we are using angles. So let's talk about classification of triangle by sides. So the first one is scalene. And a scalene triangle is a triangle in which all the three sides are of different lengths. So that's scalene. So we can see the diagram given to us. If we check out line AB, line AC, line BC, they are not the same at all. So then we call such a triangle a scalene triangle. So the next one is isosceles triangle. So from none of the sides being equal, then we are now moving on to two of the sides being equal. And so two sides in the triangles are equal, then we call it an isosceles triangle. Then from there we are now moving from none of the sides being equal to two sides being equal, from there projecting to all the three sides being equal. Then we call that an equilateral triangle. So we can see all the diagrams, and all this defines to us what each triangle is based, the classification of triangle based on what? Based on sides. So now let's move on to the classification of triangle based on angles. Then the first one we look at is acute triangle. So what do we mean by acute triangle? So it is a triangle in which all the angles contained therein in that triangle, all the three angles are less than, each of them is less than 90 degrees. Each of the angles in all the three angles, each of them is less than 90 degrees. Then we call it an acute triangle. So the next one we'll move on to is obtuse. That is a triangle in which one and only one angle is greater than 90 degrees and less than 180 degrees. Then we can see from that picture. Angle C tells us that this triangle is what? Is an obtuse triangle. Then we move on to the last one. Then we have right angle triangle. That is a triangle in which one and only angle is 90 degree, and in this case angle B is having 90 degree, and so such makes that triangle to be a right angle triangle. Then the next one is equiangular. That is a triangle in which all the three angles are the same. They have the same measurement. Then we can see that angle A, angle B, angle C, they are of the same measurement, which is 60 degree. Then so let's now have a flow chart that summarizes this classification of triangles based on side. So let's say the first one is polygon. That is their general name. So the next is what? A triangle, which is three-sided polygon. Then the next one is scalene, which falls under the types of triangle that we have. Remember, scalene is a triangle in which all the three sides are not the same. So the next one is isosceles triangle. So from none of the three sides being the same to two sides being the same, that is isosceles triangle. And from there we move on to all the three sides being the same, which is equilateral triangle. So that's the flow chart, or a kind of Venn diagram that explains what polygon. Under polygon we have a triangle. So we can see the Venn diagram. So more or less like the universal set is polygon, then the subset is triangle, and subset under triangle, then we have scalings, all these three types of triangle based on their size classification. So now let's quickly move on to classification based on angles, and the flow chart of that is given as below. So we have polygon, the general name, then the triangle being a subset, then under triangle, then we have right angle triangle. Of course, one and only angle is 90 degree. Then we also have obtuse angle. One and only angle is greater than 90 degree but less than 180 degree. And then we also have a acute triangle, whereby none of all the three angles is up to 90 degree. Then we also have equiangular, in which all the three angles are of the same measurement, that is 60 degree. So we have polygons as usual being the general one. So inside it is triangle, and inside that we have acute, inside that we have equiangular, inside that we have right angle. So we also have obtuse angle. So all these can be seen from what we are having on the chart. So we'll move on to moving away from triangles, then we'll talk of quadrilateral. What is quadrilateral? All quadrilaterals have four sides, so that's fact number one that we want to give attention to. All quadrilaterals are having four sides. All these things is fact number one. Fact number two is that they all have four angles. They all have four angles. The sum of the four angles totals 360 degrees. Then these properties are what makes quadrilaterals alike. But what makes them to be different? So we want to consider their differences. Do they even have differences at all? So let's give attention to their differences. Now the first one under quadrilateral that I want to consider is parallelogram. Parallelogram have two sets of parallel sides, two sets of congruent sides. That is, two sides are equal, then that is parallelogram. So the angles that are opposite each other are congruent. They are having equal measurements. Then that is one under quadrilateral. Parallelogram has been considered. So the next one is rectangle. Has all properties of quadrilateral and parallelogram. A rectangle also has 4 right angles. So we can see from the diagram, a rectangle can be referred to as an equiangular parallelogram because all 4 of its angles are right, meaning they are all 90 degrees. Then we move on to rhombus. Rhombus is sometimes referred to as a slanted square. A rhombus has all the properties of quadrilateral and all the properties of a parallelogram in addition to other properties. So we can see the diagram of a rhombus. A rhombus is often referred to as a equilateral parallelogram because it has 4 sides that are congruent. That is, each side length has equal measure. Then we talk of square. The square is the most specific member of the family of quadrilaterals. The square has the largest number of properties. Squares have all the properties of a quadrilateral, all the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. A square can be called a rectangle. A square can be called a rectangle, rhombus, or a parallelogram because it has all of the properties specific to those figures. Then we move on to trapezoid. Unlike parallelogram, unlike rectangle, unlike rhombus, and unlike square, who all have 2 sets of parallel sides, a trapezoid only has 1 set of parallel sides. And these parallel sides are opposite to each other. The other set of sides are non-parallel. So we can see the diagram of a trapezoid. Then we have what is called isosceles trapezoid. One can never assume a trapezoid is isosceles unless they are given that the trapezoid has specific properties of an isosceles trapezoid. Isosceles is defined as having 2 equal sides. Therefore, an isosceles trapezoid has 2 equal sides. These equal sides are called the legs of the trapezoid, which are the non-parallel side of the trapezoid. So you can see what is regarded as isosceles trapezoid from that diagram. Both pairs of base angles in an isosceles trapezoid are also congruent. Then we have right trapezoid. A right trapezoid also has 1 set of parallel sides and 1 set of non-parallel sides. A right trapezoid has exactly 2 right angles. This means that 2 angles measure 90 degrees. There should be no problem identifying these quadrilateral correctly because it's just like its name. When you think of right trapezoid, think of right angles. Then let's quickly discuss about the quadrilateral family tree. It's important to have a good understanding of how each of the quadrilaterals relate to one another. We have quadrilateral. Any quadrilateral that has 2 sets of parallel sides can be considered a parallelogram. So we can see it now, a parallelogram. A rectangle and rhombus are both types of parallelogram, and a square can be considered a rectangle, rhombus, and a parallelogram. So we can see under parallelogram we have rectangles and rhombus, and square can be considered to be a rectangle, and at the same time square can be considered a rhombus. Remember, from the properties aforementioned concerning square, talks about or speaks about all those properties help us to understand that all the properties of rectangle, all the properties of rhombus, all the properties of parallelogram are contained in square. Any quadrilateral that has 1 set of parallel sides is trapezoid. Isosceles and right are 2 types of trapezoid. So we can see all these things summarizes to us the family tree of a quadrilateral. So from the aforementioned, we've seen from the beginning the definition of polygons, what polygons are and what they are not. We've considered the classification of polygons. We've seen the concave, the convex, the regular, and the regular polygons. We've equally discussed the polygons then we have equally discussed either regular polygon or irregular polygon. We've discussed the areas of a regular polygon. So remember, there is what is called apothem. Apothem. Apothem is similar to radius in a circle. That is the distance from the center of a polygon to the side of the polygon. Then the area of a regular polygon can be tailored to area of a triangle. Remember, area of triangle is half base times height. So in a similar vein, the area of a regular polygon is half, instead of base in triangle, then we have the side length. Then instead of height in triangle, then we have the apothem multiplied by the number of sides of the polygon. So invariably, the area of regular polygon is given as half multiplied by the measurement, the length of the side, multiplied by the distance from the center of the polygon to the side of the polygon, which is apothem, multiplied by the number of the size that the polygon have. That gives us the area of the regular polygon. We've equally discussed the classification of triangle based on size, based on angles. We've seen all these classes of triangles based on these major yardsticks. Then we've given us the flow chart that summarizes everything or as far as this is concerned. We've gone to identify ourselves with quadrilaterals, the parallelogram, the rectangle, the rhombus, the square, the trapezoid, either isosceles trapezoid or a right trapezoid. So we want to employ us to go through all this and familiarize ourselves with all these properties and let it be live within our minds and our hearts. So we want to put it in our minds, we want to put it in our hearts, we want to do everything we can do to always familiarize ourselves with all these in our day-to-day activities. And there is a video that will also be attached to this teaching. Please feel free to explore the video, as it also gives us more insight into the polygon. In the next class, we will be discussing another part of these polygons and triangle, and that will be proving of the sum of angles in a right angle being two right angles, or the sum of angles in a right angle in another frame is 180 degrees. And of course, part of the video that you are going to watch in attachment to this lecture will tell us more as far as the sum of angles of a triangle being equals to 180 degrees. How did they arrive at that point? So one of the videos will be addressing that issue. So thank you and God bless. See you in the next class.